All right, today we're going to be looking at dividing polynomials. So this is chapter 4, section 3, and we're going to separate this into two different lessons. The first lesson focusing on what we call polynomial long division, and the second lesson covering polynomial division using synthetic division. So here it's just practice, practice, practice. So this first one says dividing a polynomial by a monomial. Poly meaning more than one, by monomial being one. So in a problem like this, I actually like to separate out each and every term. So we have 1, 2, 3 terms up top and 1 term in our denominator. So I'm actually going to take each term in my numerator and divide it by the term in my denominator. When we do this, it becomes a simple series of simplifying monomials. So 6 divided by 3 is 2. I have x's in both my numerator and my denominator, the largest being in my numerator. So I'll keep my x in my numerator. And then we have 4 minus 1, which is 3. We have y's in my numerator and y's in my denominator, my largest being in my numerator. So I'll keep the y in my numerator. And then I have 3 minus 1, which gives us 2. Notice there's nothing in my denominator of this first term. Let's go to the second term. We have 12 divided by 3, which is 4. My largest x is in my numerator, so it's going to stay in my numerator. We have 3 minus 1, which is 2. I have a y in both numerator and denominator, but the largest is in my numerator, so it's going to stay in my numerator. I have 2 minus 1, which gives us just that 1. Notice I'm not actually writing the 1, because if we see that we have a y there, we're automatically going to think there's only 1. Going on to our third term, I have negative 18 divided by 3, which gets us that negative 6. I have x's in both my numerator and my denominator, but the largest is in my numerator. And it's a 2 minus 1, which gives us the 1. And then I have y's in both my numerator and my denominator, but they're the same, which means they actually end up canceling out. And here we have our simplified version. Nice and easy. That's why I like to separate my polynomials when I'm dividing by a monomial. Series of more simple steps. Let's do another example very similar to it. We have each of our terms here. We have 20 c4 d squared f, but we're going to be dividing it by 4cdf. So 4cdf minus 16cdf squared, once again dividing by that monomial term of 4cdf. And then our last term is 4cdf divided by 4cdf. All right, coefficient divided by coefficient, 20 divided by 4 is 5. All right, I have c's in both my numerator and my denominator, but the highest one is in my numerator, so we'll keep it in my numerator. I have 4 minus 1, which gets us c cubed. I have d's in both my numerator and my denominator, the largest being in my numerator, so my d will stay in my numerator. And then I have 2 minus 1, which is perfect. And now looking at my f's, I have one f up top, one f in the bottom. Because they're both the same, they end up crossing out. Going to our next term, I have negative 16 divided by a positive 4, which gets us that negative 4. My c's both have the same. Oops, got a little ahead of myself there. My C's have the same, my D's have the same, but now my F's are different. I have F's in my numerator and my denominator, the largest being in my numerator. 2 minus 1 gets us 1. Now my last term, I have 4 divided by 4, which is plus 1. And notice our C's match, our D's match, and our F's match. So now we have our final answer of 5c cubed d minus 4f plus 1. All right, so dividing a polynomial by a monomial, super simple. It's a task that we've actually practiced in previous lessons, just not to this scale. So we're just building upon some previous knowledge. Now, we're going to actually divide a polynomial by a polynomial. And this is where it gets a little iffy. So you really want to pay attention. You really want to take the time to learn this. You want to make sure each term is represented when dividing. Even the zero terms, especially the zero terms. And you make sure the terms are written in descending order based on exponents. So hopefully you remember long division from elementary school. But we're going to take our x minus 5, and it's going to come out here to the front. And we're going to divide everything by that x minus 5. So x squared plus 3x minus 40. Notice our exponents are written in descending order. I have a square, and then I have a 1, and then I have no exponent at all. All right, now we have to figure out what we need to multiply this x by to get x squared. Well, in this case, what times x equals x squared? It's x. So we're going to put an x right over our x column. Now, what is x times x? X squared. And now we do x times negative 5, which is minus 5x. Now, we want to change our signs. Change signs. Right now, x squared is positive. We make it a negative. Right now, negative 5x becomes a positive 5x. What happens is these x squareds now cancel, and I'm left with 3x plus 5x, which is 8x. And I bring down the minus 40. We're going to do this step again. What do we take this x by to get 8x? What times x gives me 8x? Well, we're going to multiply by 8, so plus 8. So now we have 8 times x, which is 8x. 8 times negative 5, which is negative 40. Once again, we're going to change our signs. Positive 8x becomes negative, negative 40 becomes positive, and what you'll see end up happening is that both of these terms end up canceling and we have no remainders. So our answer is x plus 8. That is polynomial long division right there at its core. Let's do another example. All right, this time we're dividing x minus 3, so x minus 3. And underneath, in descending order, we have x squared plus 7x minus 30. All right, we need to determine what we need to multiply this x by to get x squared. Well, the answer is x, so I put it in the x column. Now we multiply the x times x, we get x squared. X times negative 3 gets us negative 3x. Once again, we need to change our signs. Positive x squared becomes negative, negative 3x becomes positive. These end up canceling. I get 7x plus 3x, which is 10x, and now I bring down the minus 30. All right, once again, what do I need to multiply this x by right here in front to get 10x? Well, the answer is 10. So now I multiply the 10 by x, I get 10x. And then the 10 times negative 3, negative 30. Hopefully at this point you know that we need to, once again, change signs. Positives become negative, negatives become positives. These end up canceling. We have no remainder, which means we have an answer of x plus 10. Nice and simple so far. That's how we like it around here. Nice and simple. All right, let's do this next one. It's written a little differently. We are multiplying, but this time we have a negative exponent. And what do we know about negative exponents? Are we allowed to have them? No. So we need to rewrite this without the negative exponent. When that happens, we have a cubed plus 2a squared plus 4a minus 9, all divided by 2 minus a. So now we're going to be dividing everything by that 2 minus a. However, we always want this in descending order. So 2 minus a is actually negative a plus 2. Our numerator stays the same. So now let's do our polynomial long division. Negative a plus 2. How many times is it going to go into? A cubed plus 2a squared plus 4a minus 9. Notice we're in descending order. So what do we have to multiply this negative a by to get positive a cubed? Well, it becomes negative a squared. Two negatives make a positive, and we need a total of 3 for an exponent. So now this becomes positive a cubed, because negative a squared times negative a is positive a cubed. Now positive 2 times negative a squared becomes negative 2a squared. Once again, at this point, we need to change signs. So my positive a cubed becomes negative, my negative 2a squared becomes positive. These cancel, and now I have 4a squared. I'm going to drop our next term down plus 4a. We're going to redo this process. It's very iterative. We do each step over and over again until we can't do it anymore. So what do I need to multiply negative a by to get positive 4a squared? Well, I need a negative 4, and then I need another a. So now negative 4a times negative a gives me that positive 4a squared. Negative 4a times 2 gets me negative 8a. Once again, what do we need to do? Change signs. Positives become negatives, negatives become positives, and then we add straight up and down. These cancel. I now have 12a, and I bring down my next term, minus 9. So now, what do I need to multiply negative a by to get positive 12a? Well, we get negative 12. All right, so now let's do this. Negative 12 times negative a is positive 12a. Negative 12 times 2 is negative 24. Once again, for the last time in this problem, we're going to change signs. So negatives become positives, positives become negatives, these cross out, but now I have negative 9 plus 24, which gets me 15. This is the first example that we actually do not have a 0, which means this right here is what we call a remainder. So our answer looks a little different this time. We're still going to have what we had up top, but it's different. We have the negative a squared minus 4a minus 12, but now we have to do plus this remainder, which in this case is 15 over the negative a plus 2, which it comes back from over here. So that is our entire answer right there. We need to make sure we're taking account a remainder and putting it over our divisor. So this is our answer. All right, looks like we have one last example for the day. We are dividing x squared minus 5x plus 6 by x cubed minus 2x squared minus 9x plus 18. We're still only looking at that first term. It doesn't matter if I have a binomial, a trinomial, or even another polynomial, bigger. You still look at that first term. What do I need to multiply this x squared by to get x cubed? Well, we just need one more x, so we multiply it by one more x. Notice I'm putting it in our x column. I take this x and multiply it by each of the three terms. X times x squared is x cubed. X times negative 5x is negative 5x squared. X times 6 is 6x. Once again, we change signs. Positives become negative, negatives become positives, and then we simplify. These terms cancel. I have negative 2x squared plus 5x squared. It's 3x squared. Negative 9x minus 6x is negative 15x. And then we bring down our next term. Once again, what do I need to multiply this x squared by to get 3x squared? Well, we multiply it by 3. Now I take that 3 and multiply it by everything in our divisor. So 3 times x squared is 3x squared. 3 times negative 5x is negative 15x. 3 times 6 is 18. Change signs. Positives become negative, negatives become positive. Notice each of these end up canceling, so I have no remainder, which is perfect because that means our answer is x plus 3. All right, so that's polynomial long division. It takes lots and lots of practice. If you have questions, make sure you're asking, reach out. Email works the best.